So I'm going to talk in this lecture about the uniform and the exponential distributions, and these are two easy distributions to do. First, the uniform is a distribution which has this formula. It's f of x equal 1 over b minus a as long as x between a and b and 0 elsewhere. So this is what the graph is. So you have a random variable that takes values only between a and b, and it's uniform. So if you were doing a histogram and all your heights are the same, then that would probably suggest to you that you have a uniform distribution. So you graph it this way, because the area of the uniform should be 1, but really we're talking about here a rectangle. So the height for this area to be 1, I want the height to be 1 over b minus a, and the width is a minus b. So when I multiply them together, I get an area of 1. That's as simple as it is, and turns out to be the mean of this distribution is a plus b over 2. The variance is b minus a squared over 12, and the standard deviation is the square root of that, so it's b minus a over square root of 12. So if I want to find the area at a point C here in the middle, again I want to find the area, so it's basically an area of a rectangle, and that area would be C minus a, that's the width, over the height, which is 1 over b minus a, or c minus a over b minus a, and that's true as long as c is between a and b. If it's less than a, my probability is 0. If it's more than b, it's going to be this whole area, which is 1. If I want the area between 2 points, again this height would be 1 over b minus a. I'll multiply that by just c2 minus c1, whatever that is, and that's all there is to it. So any area under the curve you just find by using the area of a rectangle, height times width. We know this height is not going to change, 1 over b minus a. The width depends on which point or points you pick, so I want to encourage you to go over some of these problems at the end of the chapter on the uniform distribution. The exponential distribution often arises as being the amount of time until something happens. If you're waiting for something to happen, that usually follows an exponential distribution. Time until a new car breaks down, time until the next patient arrives at an emergency room, time until the next customer arrives at a bank, or time until a light bulb breaks down, and so on. And usually this distribution has this formula: f of x equal lambda e minus lambda x, and it's 0 elsewhere. So if I want to graph it, it would look like this. Since the lambda e minus lambda x would go down all the way this, and the area under this curve is going to be equal to 1. The mean is 1 over lambda, which is here. The variance is 1 over lambda squared, and the standard deviation is 1 over lambda. So the standard deviation and the mean are the same. CDF stands for the cumulative distribution function. It means if I have a point A here somewhere, I want to find the area below that point, that would be 1 minus e minus lambda a. So if I have 2 points, a1 and a2, I want to take this whole area minus this. I have 1 minus, it gets a little bit complicated, so I can also work with the areas above a point A. So this is p of x larger than a, and it's the complement of this event. So since the whole area is 1, if this is 1 minus something, that area is going to be that something itself, which is e minus lambda a. Let me go over one of these two examples. I want to go over example 2, since the first one talks about phone booth, a little bit old. Everybody has a cell phone now. So suppose the amount of time in hours that a computer functions before breaking down is an exponential distribution with mean 1 over 100. Sorry, with lambda is 1 over 100. That means the mean is 100, which means this computer works about 100 hours before it breaks down. What's the probability that the computer will function between 50 and 150 before breaking down? So if I go to here, we clear this. So what I have now is the lifetime of this computer is an exponential distribution with mean about 100, and I want to find the probability that it will last between 50 and 150 hours before breaking down, which means I want to find this area. Okay, so that's why I represent as the probability of x between 50 and 150. Let's see what we have here. And then it's going to be e. Let me do that on this. So this is going to be equal to I want to use this whole area under the curve, which is e minus lambda a1, call this a1 by 50, minus this whole area here, which is e minus lambda a2. Okay, and this is equal to e minus lambda is 1 over 100 and a is 50, so that's 50 over 100 minus e minus lambda is 1 over 100, a2 is 150, so 150 over 100. And if I simplify this, e minus half minus e minus 1.5. So I want to calculate these two numbers and find the answer. Now that's why I have e minus half minus e minus 1.5, and that, use your calculator, will be approximately 0.384. Okay, so this is how you find these probabilities, and you can do the same thing for other ones. So if we look at the first example, it says suppose the length of a phone call in minutes is exponential with lambda 1 over 10, so the mean is about 10 minutes. If someone arrives immediately ahead of you at a public telephone booth, so still few of these probably in airports, find the probability that you will have to wait 10 minutes, or let's do the first part, at least 10 minutes before you get to call. So that means p of x greater than 10. Formula is e minus lambda. Lambda is 10, 1 over 10, and the minutes are 10, so 10 over 10 is 1, that's e minus 1. And that's approximately 0.368 again, if you do these calculations. Here's one of the nice properties of the exponential distribution. It means it doesn't have a memory, it's memoryless. Which means if you have a light bulb that's been going on for 1,000 hours, it breaks down, and you have another one that's been going on for the same time, it doesn't. The old one will function as well as the brand new one that you're going to replace the old one with. So that's a property of the exponential distribution. It says the converse. It's the exponential distribution is the only continuous distribution with this property. So there are a few exercises suggested one for you to review in addition to other problems you may have, especially the ones on the uniform and the exponential you really should do. Okay, thank you.